Hi everyone, I am Radhika. Welcome back to Datazard. Today we are going to be solving a classic LeetCode problem, reverse integer, but I'm going to do that in a very simple, beginner-friendly manner. Let's dive into the problem. So the problem states that we are given a 32-bit integer x. We need to return a result with its digits reversed. If we are reversing x, and if it causes the value to go outside of this 32-bit range, then we need to return a 0. This sounds complicated, but it is not so much complicated as long as you follow the full video and you understand all the steps that I'm doing. So let's look at the problem. We are given a 32-bit integer. This can be a positive integer or a negative integer. We'll worry about the negative, how to handle negative values later on, but let's build the logic for positive ones. Now we need to reverse its digits and then we need to check off the condition. Condition is the reversed value should not be outside 32-bit range. So this is what we need to ensure when we are reversing. Let us first try to find the reverse of an integer. Like start at the very basic. We cannot do it like a string because there is no slicing operation or no sorted operation in integers. So to do that, we will use basic mathematics that you have learned in your school. So let us say we have our x is equal to 123. This is our x. We are going to use two operators, percentage and divide. Percent will give us the digit, like the cornermost digit, and divide will give us the leftover in the integer. So let's start plugging that. First, I'm going to do our number 123 percentile 10. That will be equal to 3, and this 3 is our digit. We got our last digit. Now again we do 123 divided by 10 and we get 12, and this is our leftover x. Now here I'm just initializing result as 0 for now. Now we need to find the result. So result would be our previous result which is 0 multiplied by 10 plus the digit. So our result is equal to 3 right now. I'll explain you more why I am doing multiply by 10 plus 3 in the next iteration because it will make more sense over there. Then again I'm going to start repeating these 3 steps. So our leftover x is 12, so I do 12%. That will be equal to 2. This is our digit. And then I'll do 12 divided by 10. That will be equal to 1, and this is our leftover x. Now I'm going to find the result. So result. Now if you see currently we have 3 as result. But when we have to find the reverse of it, our reverse is what? 3, 2, 1. So we need to shift this 3 to one place over here so that we can place 2 over here. And to do that is if we multiply 3 by 10, then we have 30 and then we add 2 so that we get 32. So this is the same logic I'm going to implement here using this. So our previous result was 3. So I will do 3 into 10 plus our digit. So our digit is 2, right now 2. So this will be equal to 32. Now we have got half of it. I'm again going to repeat these steps. So it will be equal to our leftover x equal to 1%, 10, that will be equal to 1, and this is our digit. And then 1 divided by 10, that will be equal to 0. And this is our leftover x. Now again I'm going to find result. that will be equal to our previous result, which was 32 multiplied by 10. Why we are doing this? Because we again need to create a space over here. So we have to multiply 32 by 10 so that we get 320, and then whatever space we need to fill with that digit. So our digit is 1, so 320 plus 1, that will be equal to 321. So plus our digit is 1, so this is equal to 321. And now if you see here, our x is 0, which means we don't need to do any more iterations. So this is our stopping condition. As soon as x becomes 0, we have found our reverse digit, and this is our reversed number. So essentially what we do is we first do percent 10 to get the digit, then we divide by 10 to get the leftover, and the result is whatever your previous result is multiplied by 10 plus 3, because we need to shift whatever the result is to the left so that we create a space for the next digit coming in. Now we have just done the basic part of it, which is how to reverse an integer, but we are given a condition that this reversed integer, it should not be greater than the 32-bit max value. If it is, then we need to return a 0. So first we need to incorporate the condition to check whether it is greater than max value or not. To do this, instead of taking the 32-bit max value, which is a very big number, I'm going to take a small 3-digit number so that I can make you understand the logic. And then we can just replace the max value from our 3-digit number to the 32-bit max value, and it's gonna work out the same way. So let's do that. So now the next thing that we need to do is how to find a reverse of an integer and check if it is greater than a max value. Currently, I am taking max value as 321. I'm just doing this for ease, and then we can replace this max value with 32-bit integer max value. Now again, I'm going to repeat the same things that we did to find the reverse of an integer, but for every iteration, I will check if the result is greater than max value or not. Let's do that. So I'm going to take a number 223, and let's start reversing this. So the first thing that we need to do is we need to do 223 percent 10, that will be equal to 3. So this is our digit. Then we do 223 divided by 10, and this is equal to 22, and this is our leftover x. Now here our result is equal to 0 for now. So now we calculate the result. As you know, result is whatever our previous result is multiplied by 10 plus the digit. So our digit is 3, and the result becomes 0 multiplied by 10 is 0 plus 3 is 3. Now previously we just did this part, but we also have another part added where we need to check if it is greater than the max value. If you look here, max value is 321. So we need to add another step, which is if the result is greater than max value. So result is 3 greater than 321. It's no, which means we don't have to put this as 0. If it is greater than max value, I'm going to say the result as 0. So now this is our first iteration complete. Let's do it for the second time. So again, our leftover x is 22, percent 10 is equal to 2. This is our digit. Then again 22 divided by 10 to get the leftover x, which is equal to 2. This is our x. Then we find result is equal to our previous result, which was 3 multiplied by 10 plus our digit, which is 2, and this is equal to 32. Now again we check if result is greater than max. So what is our result? Result is 32. Is it greater than max? Max value is 321. No, so we continue. We repeat this again. So now our leftover x is 2. So we do 2% 10 is equal to 2, and 2 is our digit. Then again we do 2 divide by 10 will be equal to 0. This is our leftover x. Now we find result that will be equal to our previous result, which is 32 multiplied by 10 plus our digit. So our digit is 2. So this will be equal to 322. Now we check if our result is greater than max value. So our result is 322. Is it greater than max value, which is 321? Yes. So we don't need to return reverse, we need to return 0. That's what the question said. Now there is one problem here. We are calculating result which is greater than max value. And in the challenge it is mentioned that if we go back, assume the environment does not allow you to store 64-bit integer, which means we cannot store value which is greater than this max value. So in our case, we cannot store any value which is greater than 322. But here in this result, we are storing a value which is 323, and this is wrong. Now there is just a small tweak that we need to do to fix this. The tweak is we need to check first for this condition, and then we need to change our result. So we need to reverse the order. And we also need to tweak this condition. So what we are going to do is, currently what we do is our result. So result is our previous result multiplied by 10 plus our digit. We are checking if this is greater than max value. This is what we are doing currently. But if you look here, what we can do is we can say, we can bring this on that side. So we can say result multiplied by 10 is greater than whatever the max value is minus digit. Let's bring this 10 over here as well. So our result is greater than max value minus digit divide by 10. So we are going to check for this condition instead of this condition. So that we don't have to store the result value which is greater than the max value. So let's do that. So now again, I have changed the condition here. We are finding the reverse integer which we did in step 1, which is not greater than the max value which we did in step 2. But now we have added a condition that the result is also not stored if it is greater than the max value. And we're going to use this updated equation that we have derived here. So again, I am setting max value as 321. Now our x value is 223. I'm going to take the same value and let's start applying percent and divide. So first is 223 percent 10 will be equal to 3. This is our digit. Then again 223 divide by 10, that will be equal to 22. This is our new x. Currently our result is 0. And now, as I said, we can't do operations like first updating the result and then checking the condition. We first have to check the condition and then add the result or change the result. So let's do that. We need to check for the if condition, and the if condition that we are going to use is this equation. So I'm going to check if the result is greater than whatever the max value is minus the digit divide by 10. That's exactly what we have derived here from this equation. So our result is 0. Is it greater than whatever our max value is? So it is 321 minus digit, which is 3, divided by 10. Is 0 greater than 318 divided by 10? So is 0 greater than 31? No. So we continue to the next iteration. But before that, we need to update our result. So our result will be equal to previous result into 10 plus the digit. Digit is 3. So this will be equal to 3. Now I'm going to repeat this again. So our leftover x is 22. So we do is 22. What is 22% 10? That will be equal to 2. And this becomes our digit. Then we do 22 divide by 10. This is equal to 2. This is our new value of x. Now first we check for condition. So we check if result is greater than max minus digit divide by 10. So what is our current result? It is 3. So is 3 greater than, our max value is 321 coming from here, minus digit, which is 2, divide by 10. So is 3 greater than, 321 minus 2 is 319, divide by 10. So is 3 greater than 31? No, which means we can update our result. So our result will be equal to previous result, which was 3 multiplied by 10 plus the digit. Digit is 2. So this will be equal to 32. Now because we have not reached our stopping condition, which is either x is equal to 0 or we find that our result is greater than max value. So now we're going to repeat all of this again. So now I'm going to write our leftover x, which is 2 percent 10, that will be equal to 2. This will be equal to 2, which is our digit. And we do 2 divide by 10, which is equal to 0, and this is our x. Now we check for condition. So if our result is greater than max minus digit divide by 10. So our result is 32 right now, is greater than, our max value is 321 coming from here, minus digit. So digit is 2. So 2 divide by 10. So this is equal to 32 greater than 321 minus 2 is 319 divide by 10. So 32 greater than 31, because we are doing division and we are only taking the integer part. So it's 31. This condition comes out to be true. Yes, this is the case. Our result is greater than our max value. As this is true, our result now should be equal to 0, because we don't want our result to be greater than max value. So this is how we solve the problem. So the stopping condition could either be this, if this comes first, or figuring out that our result is greater than the max value. Whichever happens first, we'll take that as a stopping condition. I hope this makes sense in how we do it. And now let's try to put this in form of code. So the Python code will look something like this. First, we have defined max value. Similarly, here also we have defined the max value. Then we have defined result, which is the same. We have defined result over here. Ignore this sign for now. I'll come back to this. Then for x, we are taking absolute value of x, because there could be negative numbers as well, like we might need to find reverse of -1, 2, 3. But what we are doing here is we are just taking the magnitude of it. We are ignoring the sign. That's why I have done absolute. So the absolute value of this would be 123. And then this would match what we have done over here. On this side, we know that our stopping condition is when either x becomes 0 or when this equation becomes true. So while x is not equal to 0, that's what the condition we have put. What we do is we are trying to find percent of x and then divide by x. Percent of x gives us digit. This is what exactly I have written here. And x would become x divided by 10. This double sign is for integer division. So we only get int value. We don't get a decimal value with this. Then again, we are checking this condition over here. So if result is greater than int max minus digit divide by 10, this is again integer division, so that we only get the integer part. If this condition becomes true, that means we are here, then we put result as 0 and we are doing a return statement, which is again our stopping condition. We move out of this loop and we return the result. If this is not true, then all we need to do is we need to update result, which is what we were doing over here using this equation. Previous result multiplied by 10 plus digit. So this is exactly what we have done over here. And once this loop is completed, then we return result. Now, why I have written sign over here and I have assigned sign over here is because, like I said, we might need to find reverse of negative integers. And in that case, our current algorithm does not take into account negative numbers. That's why what we are doing is we are first understanding the sign of this. So if x is less than 0, which means it's a negative number, then we are putting sign as -1. And if, let me just quickly erase this. So when x is less than 0, then we have sign as -1, and if it is greater than 0, then we have sign as +1, so that we can adjust the sign at the very end. If this condition becomes true, that is our result becomes more than this max value that is defined, then obviously we just need to return 0 and we don't need to worry about sign. But if this full loop completes and our result is less than the max value that we have defined over here, then we need to adjust the sign, and all we are doing is multiplying this sign variable by the result. So if it is a negative number, we'll multiply it by -1. If it is a positive number, we will multiply it by 1. And that's how we will get proper signs in our result. So if it is -123, then its reverse should be -321. That's why we are multiplying -1 by 321 that we will get from result, and that will be equal to -321. However, if it is +123, then our result should be 321. So here again, what we are doing is we are multiplying +1 with the result, which is 321, and that's how we are getting 321. This is the final Python code. I hope I was able to make it clear as to why we are doing what we are doing. If you have any questions, please put them out in the comments below. Thank you for watching. I'll see you in my next one.